Hello everyone, and welcome to another tutorial on our series that we have for doing a USB to serial converter. Today we're going to actually start looking at some CAD software. So yay! We're going to be using the Eagle CAD, which I've shown you in previous videos, and we'll be starting the schematic capture. So let's go ahead and let's take a look at this. When you first open Eagle, you're going to get the control panel, is what it's called. And basically you have all your libraries. And see, this is what I like about Eagle. Look at all of these libraries. Just tons and tons and tons of libraries. Everything from memories, MEMS devices, optocouplers, optoelectronics of all kinds, potentiometers, just everything you could think of. All kinds of stuff, Texas Instruments, ST Microelectronics, Maxim Semi, just all that stuff. You have libraries for tons and tons and tons of parts. And that's in your libraries. Now, where we're going to be is under Projects. I've got in our Lessons folder, I've got our USB lesson. I've already got a schematic that I've kind of pre-made, but I'm going to show you how to create one from scratch. Let's go ahead and you can create new folders just by new folder or whatnot. It's pretty standard. You can do a new project, which will build a new folder and keep everything in there. For right now, what I think I'm going to do is I'm just going to go up here to File, and I'm going to say New Schematic, just for now, just so I can kind of show you how to set up a schematic. Okay, right now, this is your schematic capture. We look at your little crosshair right here, means 0, 0. As you can see up here, if you watch, this will tell you where your coordinates are, and if I go down there, it's 0, 0. So there's your origin. Right now, it's in inch. I like to put mine in mils, which mils, those of you who don't know what those are, that measurement is basically thousandths of an inch. And so what we're going to do is if you type anything you type while you're working will come up here, and this is kind of your command window. For those of you that have used AutoCAD or some CAD softwares that have the command window, that's basically what this is. So we're going to type in grid, we're going to type in on to start with, so turn it on. And for those of you that like kind of more of a GUI interface, right up here, if you see this, it says grid. Click on it, you basically can do the same thing. You can turn on and off, you can set up the size and all the stuff, but honestly I like learning the commands, because switching between units and switching basically your size of your grid and everything, it works a little better if you just type it. And it's very simple. Like for this one, you say grid mil, and I'll give you in mils. Right now it's set to 100 mils, or basically yeah, like 0.1 inches, which is what we saw before. If you do grid inch, then you get the 0.1. So grid mil, we're going to do mils, and I like to do 100 mil grid spacing. Sometimes I will do 50 mil grid spacing, and all you do is just type in grid 50, and it gives you 50, and that's kind of more finer. But for right now, we'll do 100. That's fine. That kind of gets your grid set up. Now, first thing you need to do is you need to put a title block in. Now, over here in your tools, you've got this tool, which is your Add tool, which is basically your parts menu tool. You click on this, and it's going to pull up the Add menu. And now you're going to have a ton, all those libraries that we saw before. Here's where you're going to pull the components in at. It gives you over here, it'll give you a short description. It'll also give you, in this window, it'll give you what the schematic symbol will be, as well as it'll show you the footprint for it, which is very handy because you may want you may have 2 or 3 things that have the same schematic symbol, may have different footprints, such as you may have something that's a through-hole part or something that's a surface mount part, but they both have the same schematic symbol, but yet you may want the surface mount component rather than the through-hole part. So that's nice that it'll show you both of those, and most schematic softwares will do that. So what we're going to look for is we're going to look for a title block, and they're called frames. So I'm going to click in here and I'm going to type F, and that'll take me down to the F's. Okay, and let's look around through here, and we should find frames. If we open up frames, you have a bunch of different ones. Like you even have 11 by 17s, 70 by 22, 22 by 34, you know, all those different ones. We're going to use this one up here, this A3L. It's a nice big one that you can have. And so all you do is just say OK. And then it has it, and it'll do multiples. I go ahead and center this on my origin, left click once, and that puts it in. Now see this, it builds it so you can click multiple times and put in multiple parts just in case you have multiple occurrences. Well, since we don't have any multiple occurrences, we're just going to go ahead and hit the escape key. It's going to bring us back to our add menu. So that gives us our title block. So that puts us our title block in. Now we need to add the MCP 2200, which is the chip that we're going to be using. That's the receiver transceiver chip that does our USB stuffs for us. So I'm going to come down. You can get to it one of two ways. You can go to microchips, find let's see, Maxim. There should be a microchip. There it is, microchip. Come in here and look for it. It's the MCP 2200. Okay, here it is. So you can go that way, or you can do a search. So let's say, you know, I was just at the top of this. I know exactly what I want, so I can click down here in the search field, type MCP 2200, hit enter, and there it is. And see what I was talking about? It gives you the schematic symbol as well as it shows you the footprint for it. And this is in an SSOP 20. So it lets us know what the package is and all that stuff. So I'm going to go ahead and click OK. And so that's going to give us that. And we're going to drop it in. And that's pretty much it. And then our next one is we're going to need a Max 232 chip. So again, I'll show you. If you type M, takes us to the M's. We got Maxim. We're going to go down to the Max, and we want a Max 232. And I like surface mount stuff. We're going to try to make this a surface mount board. And see, here's what I was talking about. See, the symbol is exactly the same, but it has two different footprints. One is the traditional DIL16 through hole, and the other one is an SOIC. And so we're going to choose this one since we like surface mount stuff, hit OK, and then plop that in. That's pretty cool. So we got that. We're also going to need a D-sub connector. And so what we're going to do is you just type sub D or sub, yeah, sub. There we go. And it's in the con-sub D connector folder. And see, here's, I like the F09 series, and you could get a surface mount one, or this one I think I kind of want to do a through hole part, so we'll grab this one. It's through hole part for this one. That way I like the through hole one better than the surface mount, because a lot of times surface mount stuff, unless it has some sort of through hole, if you're going to be plugging stuff into it, usually you're pushing a lot of force on the connector when you plug something into it. And surface mount, you're just relying on excuse me, you're just relying on the glue, basically, that's gluing the pads down to the board to take all that force. And a lot of times, sometimes with a high pin count, like 9 pins or the 25 pins, usually you have enough pads that it can take that force, but sometimes it can't. You'll end up ripping the pads off the board, and so that's no good. So in high force situations, a through hole part is usually better in that sense, because it goes all the way through the board. You're actually pushing against the board instead of against the pads. So I'm going to do that. So we're going to drop that in. Okay, hit escape key to bring us back. And I'm going to go ahead, and that's basically how you land parts in here. So I'm going to go ahead and pause and put the rest of the parts in for us. So I'll be back in just a second. Okay, I have returned, and so now I've got a bunch of parts laid out. What I did was I've got a 12 megahertz crystal that's laid in, that we need that for this. I put a couple of LEDs that we're going to put on our GP7, GP6 pins, and that way that'll give us some indication when data is traversing, so you can see it blink, kind of like a thumb drive. I've got a USB port here. I did one of the mini USB ports. You could certainly do a bigger one. And then I've got, of course, I got our D sub, and I've got some resistors and some caps that we're going to need for putting this all together. So I'll go ahead and turn our grid back on by typing grid on. I'll bring that back up. I like my grid in mils. We'll go ahead and put it back in mils. Okay, so that's how you do that. Now, I want to show you another thing. Some of these parts, like this one, if you look at it, you know that this actually has 16 pins. This part is a 16-pin deal. Well, you only have 14. So where's 15 and 16? Basically, where's power and ground? Well, a lot of these will have sub-assemblies inside of them, inside of the decal. So what you use is, if you come over here, there's a command called invoke. And what that does is, when you click on invoke, you click on this part, and then you can invoke the other piece that's in it. And so we want the VCC ground, so you highlight it, click OK, and there it is. And I like to take all my power rails and put them together. So like, I'm going to put this down here with this one. We'll just go like right there. That'll be good. And see, that way you've got U1P, that's this one. I did the same thing on this. I used the invoke command, and then that's where that came from. So we've got those. And what we're going to do is we're going to take, and now moving in this CAD software is interesting. Most all CAD softwares have two methods of manipulating things on them. They either have click the part, then say what to do with it, or choose the tool and then say what part you're going to do something to. And in this case, this one is select the tool and then click what part you're going to move or mess with or manipulate. So and then in this one, the way you move multiple parts is you're going to click on this little, you're going to click on what tool you want to use, so either copy or whatever. In our case, we're going to do move, so we have the move tool selected. Now we're going to choose the group box, and we're going to select both of these. Now if you right click, you get move group, and then you can move both of them. So interesting. So now I'm just going to put those out of the way. I'm going to put them kind of down over here. Okay, and then I kind of want to move that one over a little bit more, so there we go. Okay, now we're going to take and we're going to set up some of our stuff. I want to move this one over. Oh, and by the way, if you want to rotate stuff, you right click and you can rotate things around. If you want to mirror it, you use the mirror command, and you can mirror it, which is kind of handy to do. So anyway, we've got this now. So now we're going to do power and ground, because we can get power and ground from the PC. So we need to hook those up. So we're going to come right over to our add tool, and we're going to go to the S's, and we're going to come to supply. And here's where we have all of our different symbols. So what I'm going to do is we're going to have our VDD. So we're going to have VDD. We're going to put that there. Okay. And then we're going to have our ground. We're going to have GND. And actually, I like the A ground symbol. You could use really any of these symbols, kind of whatever you want to do. But you could use A ground or ground A. We'll use just GND. We'll do that. Why not? Because A ground is, not to be confused, it's analog ground is what it's for. And we'll put it right there. That looks good. That'll give us our VDD and our ground, because VDD is pin 1 and ground is pin 5 on a USB connector. So now we're going to wire this up real quick. We're going to wire our connectors. So you come over here to the wire tool. It's right here. Click on that. And then you click, and here's the deal. It's going to perform a basically a miter, and you can choose up here what kind you want it to be, or you can just right click and it'll change around it'll roll through them as you right click. And that's the one we want. Now to to complete the connection, we double click. And now that we double clicked, that locks it in. So let's try that again. Let's go this way with it. Now this one needs to change. I'm right clicking to change that, and then down to ground and double click. Okay, so we're done with that. So now we need to hook up 2 and 3. And 2 and 3, 2 is always D- on a USB connector. So we're going to come over here to our D-, and we'll give it a little bit of space, and then double click. Alright, then number 3 is our D+. Come over here, and oops, and if you ever mess up, like I wanted to put it over here, not this close, just hit Control-Z, and it undoes it. So then you can give it another shot, and double click. Okay, so that's got that hooked up. 4 does not hook up in this situation, so you just leave that. Alright, so that's got that connector hooked up. Now, what we're going to do is we're also going to go ahead and we'll hook up the oscillator. And the oscillator goes from oscillator 1 to oscillator 2. So we're going to do the same thing. Double click, click once, come down, over, and double click. That hooks up our oscillator. As well as we're going to hook up a reset that we can mess with externally, and also I like test points, and I'll show you how to place a bunch of test points here in a minute. I'm going to go ahead and pause for a second and go ahead and finish wiring this, and I'll have it wired here in just a second.